Okay, question 5 in what's been quite a nice paper so far. Figure 7 shows a wave on the surface of the water, and we've got these various things. Which of these shows the amplitude of the wave? So we need to know the amplitude equals half of the height. So definitely not that. That would be the wavelength, or lambda. Definitely not that. It's going to be a half a wavelength. Definitely not that, because that's the full height. So it's going to be B, half the height, B. Explain why the wave is a transverse wave. So we've learned V, P, D, O, E, T. And we just change that word from either parallel to perpendicular. So the vibration or the oscillation, and we pick parallel or perpendicular. So I just write para or perp to the direction of energy transfer. So we know in a transverse wave, energy is going that way, and the vibration's 90 degrees to it. So there's my vibration, and that must be perpendicular. So to tidy that all up, leave that a little bit there. So the oscillation or the vibration, 1 mark, is perpendicular or 90 degrees to the direction of the energy transfer. If you can't remember that word, please remember 90 degrees. On to the next one, we've got a ripple tank, and we can see we've got a lamp above, and I'm assuming it's a strobe lamp, which just means it flashes with a certain frequency. It just looks like a normal lamp. And as the waves move across, we can see them a little bit larger on a piece of paper underneath. And that's because if we imagine a wave where there is a peak, here's my piece of paper underneath, that will appear darker and this will appear brighter, because more light can get through the trough, less light can pass through or transmit through the peak. Okay, so a student has a stop clock and a ruler. Describe how they could measure the frequency. Well, we'd pick a point, and I pick a point a little bit further away, so I've got more time to react. And then I'm going to just count the waves. 1, 2, 3, 4 as they pass by. I'm going to time it. And frequency equals the number of waves divided by the time. So our model answer, how can they measure the frequency? Pick a point and count the number of waves that are passing. Measure the time, and frequency equals waves over time. And you can pick whatever your time. I always suggest use 60 seconds, use a minute. Describe how they could measure the wavelength of the ripples. Well, the first part is, if the waves are moving, that's going to be tricky. So what I'm going to do is I'm going to use a stroboscope that flashes with a certain frequency. And when the frequency of the stroboscope matches the frequency of the waves, they will appear to stop. Now, they haven't really stopped. It's just in between the flash, this wave's left and another one's replaced it in exactly the same place. So the crucial part now is, well, I need a stroboscope. This will make them appear, and then I measure at least 10 waves and calculate a mean in different places. Okay. So set the frequency of the stroboscope to match the water waves. So they appear to freeze on the screen here. Next part, get a ruler, measure it 10 times. So use a ruler to measure 10 waves, peak to peak, in different places and calculate a mean. And that's your model answer. So to just go over that, we're going to set the frequency of the strobe to equal the frequency of the waves. They will then appear to stop or freeze. Get your ruler, measure 10, peak to peak, in different places, calculate a mean. There's your model answer, and that could really go to more marks if needed. And the next one, we've got in a swimming pool, a wave has a wavelength of 4 meters. Perfect, we don't need to change that. And a velocity of 0.8 meters per second. Lovely, we don't need to change that. Calculate the frequency, and they give us this. So we can see I need to move that. So divide both sides, and we're left with F equals V over lambda. Or you can use your Fox's stab whales, and we're after the frequency. So that's the speed over the wavelength. Now, one of the big mistakes people made on the mock is they just didn't pick the right ones here. So this must be the speed because it's in meters per second, and that must be the wavelength or lambda. And we're away. So frequency equals speed over wavelength, 0.8 over 4 equals 0.2 hertz.